They do want to know everything about you.
Okay, so we took our test halfway through chapter 4 just because there's a lot of stuff. I said chapter 4. Halfway through chapter 2 because there's a lot of stuff in chapter 2. But this goes right with what you did on your test, that third page. That was only 2 problems. It said find all the zeros in that page. It goes right with this. So we said before that a polynomial could have no more than n zeros if it's degree n. Well, the fundamental theorem of algebra says that a polynomial of degree n will have exactly n zeros. So notice that it says exactly n complex zeros because they may be imaginary zeros. But if you have a degree 3 polynomial, there will be 3 total zeros, including real and imaginary. That also includes repeating zeros. So if you have a multiplicity of 2, that 0 counts twice. So you have to think about that as you're doing that. You learned this last year too. Maybe. Something maybe that you didn't do is the linear factorization theorem. And the one on the test from the last chapter where I asked you to find the remaining factors, that's using the linear factorization, right? A lot of times we ask for the zeros and we say x equals 2, x equals 3, but the linear factorization theorem just says that you can always write out the zeros as factors. And it even says of degree n, there will be precisely n linear factors. So if you have a degree 5 function, you could write that out as the product of 5 linear factors. And underneath here, I wrote it with variables, with letters, where the C's represent your zeros. So like think about a function like this. You could say like x minus 3 times x minus 7, right? That looks really nice. Complex zeros, that would be the factor like x minus 2i. That's a linear factor. Yeah. Could be a square root. We're going to do a really ugly one today. So, going right with that idea, complex zeros never appear by themselves. Complex zeros are always in pairs. So it says if a polynomial function has real coefficients, if a plus bi is a 0, then its conjugate, a minus bi, is also a 0. And that should sort of make sense because when you multiply a plus bi times a minus bi, doesn't it turn out to be a lovely real number? Because if I FOILed this out, I would get a squared, and then the negative ABI, positive ABI cancels out, and then this is minus b squared I squared. And what does I squared equal? Negative 1. So that's really a squared plus b squared. We did that on our chapter P test, chapter 1 test. You had to simplify imaginary numbers. Justin!
Sorry.
You're about to move up here. That's your only chance, and then you're in the dunce chair.
Do it.
No, give him a dunce hat. I want to watch that.
He just untied Savannah's shoe for no reason.
And it was like double knotted.
So, hey, does this look familiar to the question on the test that you just took, the very last question on the test?
Oh, no, I didn't do that.
Yes, it does.
Except it's an imaginary 0, but it says find a polynomial with the given zeros. So if negative 2 is a 0, what is the factor? If 3 is a 0, what is the factor? If 2i is a 0,
So then, do we have to have an x plus 2i?
so it doesn't tell you that negative 2i is a 0, but imaginary zeros are always in conjugate pairs. So if 2i is a 0, Sean, you're exactly right, then negative 2i is also a 0. So you also have to have x plus 2i. If you don't do that, you'll have i's in your answer, and our polynomials don't ever have i's in them, right?
Well, that's pretty creepy that they don't have eyes.
What did most people forget on the test?
Everything.
That.
White.
That, yeah, I forgot that.
Do you
Sean,
get
didn't you say there's a cloud in Wolfville?
Yes, there is.
Don't go to Wolfville, honey.
do you get to leave it like this?
No, you have to.
So I'm gonna FOIL these two out. So that would give me x squared, and then minus 3x plus 2x is just minus x. 2 times negative 3 is negative 6. And then my other piece of advice to you is FOIL your conjugate pairs together, because otherwise you're gonna have i's in your problem, and it should all work out, but it becomes really ugly algebra. So FOIL that out, and you should get something that's a real number, or x. Okay, so there's 12 questions. After you get through the 12, there's going to be 20 questions, but you don't have to do those 20, you just guess on them. So when you get done with 12, it'll then say 1 of 20. That means you passed. Then you just skip them, and then in the last few more questions.
I think I got it.
I didn't like how it automatically filled in all my
Because it knows you. And that's just Google knowing you, not College Board. Because
I
Google's
feel like College Board still keeps
They're like there's the NSA.
Sean, what do you got?
And then there's
College
X
Board's like
to the
right
fourth
there.
minus x cubed minus 2x squared.
Oh, I don't know. I'm not there yet. Okay. I'm just doing this
I
part.
told you I thought I had it.
I thought you meant just this part.
Well, that's x squared plus 4.
This would be x squared plus 4, because, do I need to show more work than that? It would be x squared minus 4i squared, but the i squared is negative 1. So you're exactly right. It's x squared plus 4. Then you got to multiply all that out. Sean's way ahead. So I'm just going to multiply all of this. So I have plus 4x squared minus x to the third minus 4x minus 6x squared.
I mean, supposed to have eyes in it.
Did you see that? It's like not right.
She doesn't like that part of the board. See what I do? She scribbled.
It won't write there.
It looks like a weird check, people. It's the clothes. It's the
We'll just put the 2 right here.
Yeah. Yeah.
Give me the fish. It looks like a fish with a dot on it.
Minus 24. So, Sean, what did you get as your answer?
X to the fourth minus x cubed minus 2x squared minus 4x minus 24.
That's right. Because you got to do the 4x squared minus 6x squared, which gives you negative 2x squared. And notice there were 4 zeros up there, 2 real and 2 imaginary, so it makes sense that we have a degree 4 thing. Guess what? On the next test that you have, which should be the Friday before fall break, you're going to have to do this.
Wow.
Great. So you're going to put those grades in after fall break, right? So that I'm not grounded the entire week?
Well, it's a new 9 weeks, so
I don't care.
Still.
You just can't have it graded before 5 o'clock on.
oh, I definitely won't have them graded before 5 o'clock on Friday.
What, does anyone know when the February festival is?
The week of our fall break.
Yes. I hate when it doesn't line up with our fall breaks and you
I
can't.
think it always lines up with our
I'm not going. I'll be hunting.
I don't think I'll be working
Hunting is lunch.
last year.
It did. But ever since we've had a week off, it's been that week. Like,
Get the
like
sweet corn.
No. The chicken gizzards in Rockville.
okay, so what else are we gonna do? Write the polynomial in standard form and identify the zeros and the x-intercepts.
Oh.
First of all, what does it mean when it says write in standard form? Any idea?
Is it the, like, after you multiply it out stuff?
Yeah, you just have to multiply it out. So could you multiply this out? Yeah, go, multiply this out. We just did one.
X squared plus 9.
Say that.
You're right. Because you would get x squared minus 3ix plus 3ix minus 9i squared, which you're never going to leave I squared in your problem because it's just negative 1. So you're right. It's x squared plus 9. Standard form is multiplying it all out. So that's one thing you have to know. zeros and x-intercepts. What's the difference between a 0 and an x-intercept? If I graphed this,
I told you it's just a dotted line.
I think there's probably a place.
Oh.
Is it a diagonal line?
Yeah.
Oh, it is. It's like a big bar.
right here. Oh.
Oh.
Find the limits of it.
I don't have time for this. I have to teach math.
Sister forever.
Alright, I'll just come over here. I'll just discuss. If I was going to graph this, it's a parabola that starts where?
At 9.
Up here at 9, and which way does it open?
So it,
What are the x-intercepts of that graph? It doesn't ever touch the x-axis. What are the zeros of that graph?
none.
Wrong.
What's
9. 0, 9.
How about the 9? How's there zeros? Are they imaginary? She raised your eyebrows and gets this right.
The zeros are the solutions. So the difference between zeros and x-intercepts is the zeros are the solutions even if they're complex. So the zeros here are plus or minus 3i, right? You just set that equal to 0. The x-intercepts are where does it touch the x-axis. If there were real zeros, would the x-intercepts and the zeros be the same thing? Yes. But if they're non-real, then you could have zeros that are not x-intercepts. But the x-intercepts, there are none.
How many days are still for free?
A week, Justin.
From the 17th through the 21st. So
Well,
the
how many
15th
days
through the
until, right? Is that what you said? Or how many days is fall? You said until. Okay, so this weekend, next week.
Oh yeah, a week from Friday is the last day.
As little as possible.
Okay, so something that we didn't talk about with the last chapter of how to help you hone in on which PRZs work, which is Descartes' rule of signs. You remember doing Descartes' rule of signs last year? Descartes' rule of signs gives you a possible number of positive real zeros and negative real zeros and imaginary zeros. It doesn't give you exactly how many, it gives you a possibility. So the rule for Descartes that he came up with is that if you have a polynomial of degree n, the number of positive real zeros is equal to the number of variations in sign, so like changing from positive to negative or negative to positive, of the function, or less than that by some even number. And we'll do an example in a minute, so I'll show you what I mean. I'm never going to make you use Descartes' rule of signs, but I'm going to show you how it can help you when you have a big giant list of PRZs and you're like, where do I start? Using Descartes' rule of signs can kind of help you. You can also check your answers based on Descartes' rule of signs. So then the possible number of negative real zeros is equal to the number of variations in sign of f of negative x, or less than that by some even number. Maybe we do it, it'll jog your memory. What's tricky about this is they give you a question and they say like, how many are real zeros and how many are complex? And people want to use Descartes' rule of signs and just give that answer, but you still have to do more work than that. So that's where you have to decide, is it worth it to you to do Descartes' rule of signs? Plus it's fun to say Descartes, right? I did a report on Descartes. It's on YouTube if you want for my online class. I did a PowerPoint presentation about the life of Descartes. I have a poster somewhere up there that says, don't put Descartes in front of the horse. That's a funny joke that you don't get because you probably don't even know that phrase. Don't put Descartes in front of the horse. But it's funny to put, don't put Descartes. Never
I was wondering why that name sounded familiar. Then I remember I stared at that poster.
Yes, he died. I'm pretty sure he died of the flu.
What?
He didn't die of dysentery.
That's psychosis.
Dysentery. It kills everyone.
1650.
If you look back in history, everybody died.
He was only.
Spoiler alert.
Well, it was 1600.
Can't
So,
take
you know.
400 years.
So we just appreciate the fact that you totally polished enough to do that shit.
It's kind of dark. It's kind of darker than the red on my skirt,
Like,
but
it's
I'll
far
take
enough
it.
away that it's gonna be like, nobody's gonna be like,
All right, so you also have questions like this on your homework that say state how many complex and how many real zeros the function has. One option is you can just find them all the way we did already on the last test. The other option is we could use Descartes' rule of signs to try to help us a little bit. So here's Descartes' rule of signs. If we want to find the number of positive real zeros, we're just going to take the signs of the function. So look at f of x, and I'm just going to copy down plus minus signs. So like this is positive, this is negative, this is positive, this is positive.
That's division.
There you go.
Oh,
It's like a line. It's just like a bar that goes through.
This used to do this to me all the time last year, and I would call Jared, and I would be like, come down here so you can see it. And then he would come down here, and it would work perfectly every time. Every time.
Then
And
call
then,
down here right now.
and then he would walk away, and he would walk down the hallway, and I would write, and it wouldn't work again. And I was like, he thinks I'm crazy.
Call him right now.
it's a ghost.
It's a little.
So, how many times does it change signs? From positive to negative, that changes sign, right? From negative back to positive, that changes sign. So it changes 2 times. So there are 2, or you have to go down by an even number. So there could be 2 positive real zeros, or there could be 0
Oh,
positive
I
real
remember
zeros.
this.
See, I knew
Yeah,
you.
it was like 16, it was like 14.
Oh yeah, it's crazy.
It's crazy.
For the negative real zeros, you have to remember that you're looking at f of negative x. So that means you have to think about what would happen if you plugged a negative in for all those. Every odd exponent, when you plug a negative in, it's going to change its sign, right? But if I plug a negative into an even function, is it going to change its sign? No. So you don't really have to do all the math. You just have to pay attention to the exponents. So since that's odd, it's going to change from a positive to a negative. But since that's even, a negative isn't going to affect it, so that's going to stay a negative. Is that one going to change or stay? Because that would just change the negative x, and then the constant can't ever change, right? So that just stays a positive. So how many? It only changed once. You can't go down by an even number with 1 because you'd be a negative 1. So we know for sure there's 1 negative real zero. We also know that how many total zeros is this function going to have?
3 or 1. So
What does the fundamental theorem of algebra say? How many zeros does a function of degree n have to have?
I'm sorry, what?
Look at the front page of your notes. Fundamental theorem of algebra.
And
has a comp
Has exactly n zeros. What is the degree of this function?
3.
So there has to be 3 zeros. So if there's 2 positive and 1 negative, how many could be imaginary? None, because that already adds up to 3. So there could be 0 imaginary, but what if there's no positive and 1 negative? There could be 2 imaginary zeros. So how do we know? We just guess, right? You have to actually do it. What would the PRZs of this be? This would be an amazing test problem, right?
yes.
Because the PRZs are just factors of 1 over factors of 1. So your PRZs here are just plus or minus 1. Here's where I think Descartes' rule of sign is helpful. I know it's just one number, 2 numbers. But if we know there could be 2 or 0 positive, but there's for sure 1 negative, which one do you want to check?
Plug in there.
I would try the negative first. Now this can be a bit misleading because are there real zeros that are not rational zeros? Like it could be like -1 plus the square root of 2 or something, minus square root of 2. So just be careful on that. But let's see what happens. Hopefully it's negative. Is it -1? You get -1. Times 3. It just doesn't work. Minus 1 plus 1.
So you get -4.
It didn't work. So does 1 work?
Probably.
I'll show you what I mean in a minute. I misled you. It's not wrong. I just hope that the negative 1 will work. I get 1 minus 3 plus 1 plus 1.
Yeah.
That equals 0, which means for sure I have 1 positive 0.
Which means there's 2.
Which means if there's 1 positive, there has to be 2 positive, right? And what else do we know there has to be? Which means we don't actually even have to find them all if we can use Descartes' rule of signs. Does that make sense of what I'm saying on this problem?
We know that we have 1 positive, that means we have 2 positive.
Because the only option is 2 positive or 0 positive. You see what I'm saying? Like using Descartes' rule of signs, like there's only 2 positive or no positive. So if we found 1 positive, there has to be another one. I'll show you how we can find them all. We just don't have to. So just like you were supposed to do on your test, once you find one that works, you should divide it out. Right, and that just kind of verifies that it did work because I got 0 again. I was at x to the third, so now I'm at x squared minus 2x minus 1. I think this is the exact problem that was on the test of what was left after you divided it out. Because a lot of people tried to factor this and said that factored into x minus 1 squared.
Falseness.
But it doesn't because of that minus sign right there. Like it's not pretty. Like you have to complete the square or do the quadratic formula. So we could solve this. I really like completing the square. You guys don't, but I'm going to do it anyway. So if I'm solving this by completing the square, I'm not putting in vertex form, so that means I can move that 1 to the other side, right? And this is why I like completing the square when there's an even number and there's nothing in front. Like, I get to my answer a lot quicker than when I do with the quadratic formula. But you just got to remember, what do you put right here? Half of -2 squared, which would be?
1.
And if I'm doing it to the other side to keep it balanced, no, that's when it's on the same side, right? If I'm doing it on the other side of the equal sign, I'm going to add 1 there. Just do the quadratic formula. This factors into x minus 1 squared. I take the square root, and I get x minus 1 equals plus or minus the square root of 2, which means I get 1 plus or minus the square root of 2. I get 1 plus or minus the square root of 2. And my other answer was x equals 1. Are those all real, or are there some real, some complex? Oh!
No, that's real.
It's only complex if it's imaginary, right? If there's an I in it. This is just irrational. But these are all real numbers. So we can say there are 3 real zeros. Which means this graph would cross the x-axis 3 times, just in 2 places it wouldn't be very nice. It does still fit Descartes' rule of signs. We have 1 negative and 2 positive, because one of these is positive and one of these is negative. But I just did this because, I don't know who asked, like, how did I really know that for sure? If the question just says state how many are complex and how many are real, if you can figure that out without actually solving it all, like, you're welcome to do that, using Descartes' rule of signs and what we know. Okay? I feel like I've just, like, crushed you all. You're all so sad. All right, ready? Is this the last one?
Yeah.
It's a good one. And by a good one, I mean a crazy one.
So in other words, I'm going to be going on to the back.
You might go on the back. Find all the zeros and write a linear factorization of the function. You have to make sure you read the directions. If it just says find the zeros, your answers are just x equals 2, x equals 3. But if it says write a linear factorization, like you have to write it out as a product of the factors, okay? This one is just like one that we did on the test, where it was an x to the 4th, and I only asked you to find the rational one. But now I say find all the zeros, which means even if they're imaginary, you have to find them all. And if this is a degree 4 function, how many answers should I have? 4. Because it's degree 4.
Take your test.
So, step 1, could we do our PRZs?
She gives up. She's done.
I wonder if it lets me right over here. That's the real question.
Yep. Maybe it's the pen. It's the board. That means it's the board. Because the pen doesn't not work anywhere else.
PRZs. Factors of this over, oh hooray, it's factors of 1, right?
Yes, thank goodness.
So it's all 6 minus 6.
What are the other factors of 6?
1, 2, 3.
So we have to do plus or minus 1, plus or minus 2,
You're working so hard over
plus or minus 3,
there.
plus or minus
It's
6.
only takes 30 seconds. It still looks better if that board wasn't so stupid.
So this is where if you want to use Descartes' rule of signs to kind of help you, you can. Or if you like think that's just a wasted step and you just want to start guessing because there's only 8 numbers to guess there anyway, that's your choice too, all right? Like I'm not going to make you use Descartes' rule of signs. It's just supposed to help you. So what do you think? Descartes? No Descartes.
No Descartes.
Perfect. So I'm just going to start guessing.
So I'm just gonna start.
So I'm just going to start with 1. 1 plus 1 plus 5 minus 1 minus 6.
Boom.
Yeah.
Boom.
Like I said, just start guessing.
What should you do when you find one that works?
Plug it in. This
Synthetic
stuff.
Divide it out, yes. And since this is a 4th degree, when we divide it out, we're still going to have a 3rd degree, which means that you're probably going to have to keep guessing, but I'm going to go ahead and divide this out. So I have now x to the 3rd plus 2x squared plus 7x plus 6. I could look at my PRZs again, but they're going to be the same because it's still 6 at the end. Sometimes it's a different number, so maybe it would like reduce the number of PRZs. And I'm just going to keep guessing, but here's where I want to caution you, and I think there was one that was like this on some homework or practice test from the last chapter online. Remember that double zeros count twice, so I always do the same as you probably do, is I'm just going to start with -1, but just be aware that 1 could work again. It doesn't work in this one, but it could work again because it could count twice. And so if you check them all and none of them work, I just want to tell you, like, don't forget that the same 0 could work twice because it could have a multiplicity, but this one doesn't work. So I'm just going to start with -1, and I'm going to get -1 plus 2 minus 7 plus 6.
Yes.
My favorite problem ever.
Okay, like it's my favorite, and it's like it's off.
It is going to be awful. So I'm now going to divide again, and I'm just going to, I went over there for a reason, so I did just use this same for my synthetic division. Because now I have 1, 2, 7, 6, but now I'm going to divide out -1. You okay with that?
Sure.
Sure does not sound very convincing. And once you get to a quadratic, you should not have to guess anymore because we know how to solve quadratics by completing the square or doing the quadratic formula. Because now I have x squared plus x plus 6. And I'll do the quadratic formula this time.
Done.
Because there's a fraction, like that would be a fraction in the middle. I don't want to make it a fraction. And I feel like you guys would do. Does that factor?
Oh, no, never mind. I had it written down.
Because they're both positive, that's why it doesn't. If that middle sign, or this last sign was negative, it would factor, right? So I'm going to get -b plus or minus the square root of b squared minus 4ac all over 2 times 1. This is where it becomes not so nice. Yes. Well, I mean, it's just college board. They just want information from you. So, but this means like, yeah, fast. If you're going to go fast out, you would do yes.
What's the square root of 23 over 2?
Who cares? And then when you get to the page with your score, Tyler, I want to see it, and then you'll be done. I think you get 1 minus 24, which is negative 23. Do you agree with me on that? So my zeros are negative 1 plus or minus I radical 23 all divided by 2.
Yay.
Hey, we've been doing that since chapter P. It's just all coming together now.
You method.
So what are my zeros? I have x equals... I have x equals 1, x equals negative 1, and I have these zeros here, right? I'm not going to rewrite those, but we're just going to draw a line. You can rewrite them on your paper because your paper isn't glitching like my computer. But what does the direction say on this? Does it say write the zeros, or it says find the linear factorization? All right, that's good. You're ready to go.
Good job, Tyler, you passed.
I got a 114.
It is. You needed a 76, I think.
You like double.
Almost.
I think 120 might be the highest you can get. Just so you know. So linear factorization, we're going to write these as factors. So we're going to say f of x or y equals, what would the factor be if the 0 is 1?
He goes, what do we do?
It would be x minus 1, right? That's the 0. The factor is just, you just move it back over. And if the 0 was negative 1,
It's showing up there. Look at it.
Got the arrows.
You may want to recalibrate.
there's no recalibrating because it's a TV. All right, I'm going to write it down here. So I have x minus 1, and then what would this one be? This would be x. But then also we have to do these as factors. So think about these zeros. Like you have a 0 of negative 1 plus I radical 23 over 2. And you have a 0 of negative 1 minus I radical 23 over 2. How are you going to write those as factors?
Well,
Cry a little. And then
How did you write these as factors? What did you do from the zeros to get to here?
Just change the sign.
You just change a sign. So even though this is an ugly, ugly mess, we're just going to change the signs as we go through. So this one is just going to be x plus 1. But then this is going to change to minus I radical 23 over 2. I need more room.
oh gosh.
Oh.
I'll just rewrite it. X plus 1 minus I radical 23 over 2. And then this one's going to be x also plus 1, because that's still a negative 1, right? But then now this is minus I, so it's going to change to plus I radical 23 over 2. Don't ask me why I changed the red. I don't know the answer to that.
Oh my gosh.
So when you look in the back of the book to check your odd answers, because that's what you have to do now, right?
Yep.
Or if you're doing the online homework for extra credit, they're going to simplify this a little bit. They're going to say, this fraction's really gross, right?
Yes.
So what if I multiplied this by 2? Would that get rid of this fraction? So instead of leaving it like this, they're going to write it as 2x plus 1 minus I radical 23. And notice all they've done is they've multiplied this factor by 2, and that makes the 2x, and then it cancels out this fraction. And they're going to do the same thing for this one. They're going to say 2x plus 1 plus I radical 23. And I think we would agree it looks better not as a fraction, but it's the same thing. So especially like paper homework, on a test, on a quiz, if you left it as a fraction, I'm not going to mark it wrong. If you wrote it out real nice, maybe I give you extra credit point on a test. but you don't have to. But online, they might make you do that, so just be aware. That's linear factorization. That's gross, right?
Yes.
If you multiplied all that out, you would get the original problem.
But yeah, don't forget why equals.
I didn't. So, since we're doing book homework, I always, back in the day when I had book homework, give you an assignment sheet so that you can see the assignments coming up, kind of how many sections we're doing, and then I try to put a little joke on them. Sometimes they're about math, sometimes they're not about math.
Yeah, you should just put our names on there. You're a jerk. You're a jerk. Yes, you are.
So notice that on 2-5, there are 2 lines, and I wrote out next to it day 1, day 2, since you haven't done this before, so you didn't think to do all of that. Which means today, you are going to do 3 through 9, and this means multiples of 3. So instead of doing evens or odds, when I put a times 3 next to it, it means every third problem. So you're just doing 3 and 6 and 9. Follow me on that? Doesn't mean do them 3 times each. And then you're going to do 17 through 20 all, then 21, 27, and 30. Tomorrow we will start and I'll say, what questions do you have on the homework? I encourage you to check your odd answers in the back. The reason I really like online homework is I love that you knew right away if you were right or wrong. You should check every odd answer in a book problem. That's why they're in the back, so that you know whether or not you're doing them correctly. These questions are up for grabs on homework quizzes, which means that we could have a homework quiz any day. You need to bring your homework with you every day, and that's how I can check that you're doing them. Okay? And then again, online homework is there as well for extra help. Or if you get stuck on the book homework, maybe go to the online homework and see if there's a similar question, and you could just do the like, help me solve this or view an example to then help you with the book homework too, right? Look at that, using your brain. The mammoth joke's my favorite. That's my favorite joke.
No, I like the spider.
I like the royalty one.
Yeah, I like the royalty one.
He hit the king with the trombone. This is the slide. Trumpet, whatever.
These are not math. Usually they're math. This was my first non-math one of the year. So, okay. Don't forget about test corrections. See me if you